Yeah, hello, good evening. I've shared my screen. Okay, so I think all of you are new in my class. Two students are showing, Lamya and the next one, Abdul Rahman. Okay, my voice is clear to all of you.
Yes, sir.
Okay, so today we are going to start our class of physics. Okay, so first I'm going to discuss what is your syllabus. Okay, so what is your entire syllabus which we will cover. So in your class 12th, the syllabus starts with uh,
Okay, sir.
the topic. Yeah, the topic, the first part we can consider it as the electro electrodynamics part. Okay, so in this part the first chapter belongs to your electrostatics. Okay, the first part is related to electrostatics. So next in this chapter, in this series, the next chapter is related to your potential and capacitance. Electric potential and capacitance. Okay, and after this we will study the third chapter in this series is magnetic field and magnetism. Okay, magnetic field and magnetism. And in this series, the next chapter which we will study is electromagnetic induction. Electromagnetic induction. Okay, so electrostatics, potential and capacitance, magnetic field and magnetism. Next is electromagnetic induction, and the last one is alternating current. Okay, so this belongs to electrodynamics and alternating current part, in which we will start our study from a charge to current. Okay, we will start our study from charge to current. So this is the electrodynamics part, okay, which will cover your I think 70%, more than 60% syllabus. Okay, so it will took I think 35 to 40 lecture to cover this part of the syllabus. Okay, so next part is your optics part. Okay, in this we will study the ray optics. Okay, optics is a study of basically light. In electrodynamics part, we will study the property of charge. Okay, it's all about charge at rest, and another half part is charge in motion. And in optics, basically we will study the properties of light. The first chapter regarding to its ray optics, and another chapter is regarding its wave optics. Okay, so this is a part of optics. Next we will study the modern physics part. Okay, in modern physics, basically we study what is atom, a chapter related to atom. Okay, how electron moves in a atom, and what kind of laws it follows basically. Okay, so Bohr's theory and some theory related to atom we will study in this chapter, atom. And another part is of the syllabus of modern physics. The first one is basically dual nature. Then we will go to the atom. First is dual nature of light and particle. Okay, so next is atom, and another chapter is nuclei, properties of nucleus. Okay, and radioactivity, nuclei and radioactivity, radioactivity. And the last chapter of your syllabus is semiconductor and semiconductor devices. So this is a summary of your syllabus. Okay, so we will start our study from charge, and after that in optics part we will study the properties of light. In modern physics we basically study the properties of atom and nucleus, and after that we will study what is semiconductor and semiconductor devices. Okay, so today I'm going to start our first chapter, which is electrostatics. The first chapter, which is chapter 1, in which we will study electrostatics. Okay, so chapter number 1, electrostatics. Okay, so what is electrostatics? Means electrostatic is a word which made from two words, electro and statics. Basically, we consider this as an electron, or we can say a charge at rest. Okay, so we can define this word as charge at rest. Okay, charged body at rest. A charged body at rest. A charged body or charged particle at rest. Okay, so this is all about this chapter. But the point is, what is a charged body? Means what is a charge? Okay, what is a charge? So before the discovery of charge, people know the only one intrinsic property of matter. Which is mass. So mass, we define mass as intrinsic property of matter. Means we can't define mass in some other parameters. Other parameters can be defined in terms of mass, but we can't define mass in other parameters. Mass is a fundamental one. Okay, so we define mass as a intrinsic property of matter. Okay, mass is a intrinsic property of matter. So mass is not only intrinsic property of matter. Okay, so when people find, because two massive body has only attractive properties. But later some people discovered that two bodies not only attract, they also repel each other. So what kind of forces which is responsible for this repulsion? Okay, if I consider two massive bodies, then they only attract each other. So what kind of forces involved for repulsion? Okay, and what's the fundamental nature of matter which causes repulsion? Okay, so for that people discovered new parameter which is charge. Okay, charge. So just as mass, charge is also an intrinsic property of matter. Okay, charge is an intrinsic property of matter. Property of matter. Okay, charge is an intrinsic property of matter. Now next we talk about mass is intrinsic property, and due to this property there is a force exist. What kind of force exists due to masses? You already studied in your previous classes. What kind of force that is? Anyone? Anyone? What kind of forces exist due to mass of a body? If I bring two massive body very close to each other, then what kind of force they apply on each other? What kind of force exists between this earth and moon? Are you listening? Lamya and Abdur?
Yes. Yes, sir.
Yeah, hello. Yeah. So
Yes, sir.
Abdur, are you listening me, Abdur? I'm not getting your response. Hello? Okay, maybe he's not able to speak. So due to mass of a body, a gravitational force exists. Okay, gravity exists due to mass. Okay, so as masses are responsible for gravitational force, masses are responsible for gravitational force Similarly, charges are responsible for electrostatic forces, the electric forces. Okay, so charges are responsible for electric forces. Okay, electric forces. So now next mass have only one property, which I told you, that they only attract each other, but charges attract and repel each other. Okay, so there are two kind of charges. There are two kind of charges. There are two kind of charges. Two kind of charges. Okay, charges. Okay. So one charge is positive and another charge is negative. One charge is positive charge or another charge is negative charge. Okay, so positive charge and the example of positive charge means a particle which has positive charge is a proton. So we can say that proton has positive charge, or we can say proton is positively charged. Proton is positively charged and electron is negatively charged. Okay, one thing I want to modify in my definition, that charge is an intrinsic property of matter, but if I precisely say, then the matter we can consider matter or fundamental particle. Okay, so the better definition is charge is an intrinsic property of fundamental particle. Fundamental particle is also matter, but it's better to say fundamental particle. Okay, so this is the correct definition of charge. This is the correct definition of charge. Okay, now one more thing. Yeah, so let me highlight this point. Charge is an intrinsic property of fundamental particle. Okay, so this can be 1 mark question. What is charge? Define charge. So you will write the definition of charge as charge is a intrinsic property of fundamental particle. Now a question arises, what is a fundamental particle? Okay, what is a fundamental particle? So the fundamental particle are basically particles which exist in atom. Okay, atom is not fundamental. Fundamental particle such as proton and electron. Okay, we consider these two particles as fundamental particle. Okay, is it clear?
Yes, sir.
Okay, so next I'm going to discuss so proton is a positively charged and electron is negatively charged. Proton is a positively charged and electron is negatively charged. Okay, another particle which is neutron. So neutron is neutral in nature, means it's a neutral. Okay, we can consider it has zero charge, or it has equal positive. If a body has equal positive and negative charge, then it's a neutral. Okay, so we say that neutron is neutral in nature. Or we can consider it has zero charge, zero net charge. If a body has equal amount of positive and equal amount of negative charge, then it's a neutral. Okay, in nature, all of the things which basically we use in classical world, all of them are neutral. If a body has a lack of charge and if it has some more charge in compared to other body, then it will show some behavior such as attraction or repulsion. Okay, because the electric forces or electrostatic forces are much more stronger than gravitational forces. Okay, so this force is more powerful than gravity. Okay, so the force due to these charges is much more stronger than gravitational force. Okay, so there are two kind of charge, as I discussed. The first one is proton, and the first one is positive charge, and another one is negative charge. Okay, so so the idea of this positive and negative charge was totally arbitrary. Okay, so at the starting, when Benjamin Franklin discovered these two behavior of charges, then he arbitrarily choose positive and negative. Okay, maybe he can consider negative as a positive and positive as a negative. So this is totally arbitrary. He choose, okay, it has some different property, let put a positive one, and it has a different property from positive one, so let it consider as negative charge. Okay, so and the existence of this positive and negative, I told you, the proton is a negatively charged and proton is a positively charged body and electron is a negatively charged body. Okay, so if you want to imagine these charges, so let me draw an atom. Okay, suppose I consider suppose this is a nucleus of atom. Okay, so in this atom, inside the nucleus, proton exists. Suppose this is proton, positive charge, this is another proton, this is another proton, this is another proton. Okay, and it also has some neutron which has neutral bodies, but I am considering only positive. Okay, so around this positive charge some negative charge exists, such as electron. So suppose a electron exists here, electron exists here, which is orbiting in different orbits. Okay, a electron here and electron here. Okay, so this is all about atom. Okay, so if a atom has 4 positive, 4 negative, then we consider it as a neutral atom. Okay, so in reality, basically, atom, we consider an atom which is in neutral in state have equal amount of positive and negative charges. Okay, so this is just explanation of how charge exists inside the atom or around the atom. Now next part, important point is charge is a scalar quantity. Charge is a scalar quantity. Okay, what about mass? Mass is a scalar or it's a vector?
Vector.
No. Mass is also a scalar. Okay, so mass is also a scalar, and such as mass, charge is also scalar. Okay, is it clear? Mass is also scalar because it has only magnitude, and charge is also a scalar quantity. Charge is also a scalar quantity. Scalar quantities are those quantities which has only magnitude. Okay, which has only magnitude. They don't have any direction. Means if I consider a 10 kg body, okay, 10 kilogram body, then it has only scalar quantity. It has only magnitude. But if I throw that 10 kg body in a particular direction, so in that case it has magnitude as well as direction. Okay, so this is the important point. Charge is a scalar quantity. This is important point, that charge is a scalar quantity. Okay, charge is a scalar quantity. So this point is important. There are two kind of charges. One is positive charge, and another is negative charge. And another important point is charge is a scalar quantity. Okay, so up to now I discussed three very important points. The first important point was the definition of charge. This point is important. Okay, the red color which I marked is important for you. Charge is an intrinsic property of fundamental particles. This is important. This is a definition of charge. Next important point is there are two kind of charges, positive charge and negative charge. Okay, and next point is very important, which is charge is a scalar quantity. Next point is charge is a scalar quantity. And another next important point, which I'm going to told you, that the unit of charge is the SI unit of charge. SI unit of charge is Coulomb, which we call capital C. The SI unit is Coulomb. Okay, SI unit of charge is Coulomb. Now next, another important point. These are important points related to charges. Okay, next important point, which is the fundamental value, the very basic value of charge, means a minimum number in terms of charge exists, a minimum number. Okay, so that charge we consider as charge on electron. So charge on electron is 1.6 into 10 raised to the power minus 19 Coulomb, and the similar charge exists for a proton, 1.6 into 10 raised to the power minus 19. the charge on electron is -1 and the charge on proton is -1, but magnitude is same. Magnitude is same, which is 1.6 into 10 raised to the power -19 coulomb for charges on electron and
So
proton.
1.6 into 10 raised to
Power -19 coulomb. So this is the minimum amount of charge. Okay, we consider the electron on the charge on 1 electron, 2 electron, 5 electron, or 5 proton. But this is the minimum number, minimum amount in which you will study charges. Okay, so whenever we talk about 5 electron, 6 electron. Okay, so it means 5 times this quantity, 6 times this quantity. But this is the this is the very fundamental number for existence of charge, fundamental amount, basic amount of charge. Okay, basic amount of charge. So any question, Ramya?
no sir, no sir.
Okay, so write down these important points as the red color mark. The first one is definition of charge. Okay, and the next kinds of charges, and the another one, charge is a scalar quantity. These are important point. And SI unit of charge is coulomb, and charge on electron is 1.6 into 10 raised to the power -19 coulomb. Okay.
Yes sir.
Okay, next point. So I want to give a very small comparison of mass and charge. Very small comparison of mass and charge means how charge is different from masses. Okay, so mass, if I compare mass and charge, a very small comparison for better understanding of charges and masses. Okay, so if I consider mass, okay, so mass has only positive values. It has only positive. Mass always exists in the term of positive. Okay, and charge exists, as I told you, it has positive value as well as negative. Okay, charge exists in two forms, positive charges and also negative charge. Okay, and due to a positive charge, a force exists which we call gravitational force. Gravitational force. Okay, the force exists between moon and earth is gravitational force. Whenever we put two massive bodies very close to each other, then a force exists which is gravitational force, and this gravitational force is attractive. This is attractive in nature. This gravitational force is attractive in nature, and due to these charges, means if a body is positive charge and negative charge, then due to these charges a force exists which is electrostatic, electric forces. Electrostatic force. Okay, and this force is attractive as well as repulsive. Attractive and repulsive. Repulsive. So if I if I consider two charges which are both are positive, then what happened? They will repel each other. And if I consider a positive and negative, then they will attractive. Okay, so here we can write as similar charges repulse each other, and dissimilar charges are attract each other. Okay. Okay, so if I consider a positive and a positive, then what happened? They will repel. They will repel. And if I consider a negative charge, then they also repel. Okay, or if I consider a positive and a negative, then they will attract each other. Okay, so you can write same charges or similar charges repel. Okay, and different charges charges attract. Okay, so this is a small difference between mass. Another important point which I want to discuss with you is if you take a massive body, and if a massive body is moving and if its velocity is increasing, so mass basically that massive body depends on speed. Okay, so mass varies with speed, okay. So suppose if a massive body is moving, so its mass varies, its mass changes, okay, but charge remains same with speed. Charge remains same with speed. Okay, so this is a very small comparison between mass and charge, and the most important comparison are the most important points are two: the first one and second one, which I am again writing with red color mark. The first difference is like mass has only positive values, and charge exists in both positive and negative. And due to mass, gravitational force exists, and due to charge, electrostatic force exists. Okay, electrostatic forces are attractive and repulsive. Okay, so these 2 points are important. Okay, and there is another point which I discussed: the mass varies with speed and charge remains same with the speed. Okay, but these 2 points are important. These 2 points are important. What are important points? I am just marking with red color. Okay, so now up to now, any question? Any question? Any question?
No, sir.
Okay, so next part I'm going to discuss what is charging of a body. What is a charging of a body? So how this positive and negative charge basically exist? Uh, how this negative and positive charge exist on a body? So that's basically I'm going to discuss. First, I'm going to discuss what is a positively and negatively charged body. Okay, so charging of a body. Next point I'm going to discuss is charging of a body. Charging of a body. Okay, so if a body, suppose I'm considering a body which has, okay, if this body has some negative charge and some positive charge. Suppose I consider 1, 2, 3, 4 positive charge. Okay, and next I'm taking some negative charge over this body. Suppose I am taking some 3 negative charges. Okay, so in this case we say that this body is positively charged. Okay, this body is positively charged. This body is positively charged. Okay, next I am considering another example. In this example I am again taking few charges. The first I am considering some positive charge. Okay, suppose again this body has same number of positive charge. How many number of positive charge? Again 1, 2, 3 and 4. Now this time I am taking few negative charges. So in this time I am considering 1, 2, 3, 4 and 5, maybe 6 or 7, whatever I can. I'm just increasing charge. So in this case, negative charges is more than positive charges. So we consider this body as negatively charged. We consider this body as negatively charged body. We consider this body as negatively charged body. Is it clear? So in my next example, I'm taking some positive and negative charge. So this time I'm taking first first positive charges, again plus 4 positive charges, and minus and minus. Okay, so what about this body? Is this positive or it is negative? What kind of behavior it will show? Anyone?
Same,
Anyone?
sir.
Same or any better answer? Same means what kind of same means? The charge is equal amount of charges, but what we call this body?
Repel.
Huh?
Repel.
Repel, not repel. Okay, it has equal number of positive and negative charge, so the behavior is neutral. Okay, it has equal number of positive and negative charge, so we consider this as neutral. It will show neutral behavior. Okay, it's a neutral, or we can consider it as zero charge. Okay, no charge, zero charge, or no charge, or we can say neutral in nature. Neutral. Okay, so if a body has more positive charge than negative, then it's a positively charged. Okay, for like this example, more positive charge. Okay, more positive charge, then it's a positively charged. And if has number of negative charge is more than positive charge, okay, if it has number of negative charge more than positive charge, then this body is negatively charged. And if number of negative and positive charges are equal, then we called it neutral, or zero charge, or no charge. Net charge is zero, or we can say that this body has no charge or neutral in behavior. Okay, so how can we charge a body? Basically, one important thing that positive charge never transfer, only negative charge transfer. Okay, only negative charge transfer. So whenever suppose I rub this pen over my head, okay, so in this case maybe there is some transfer of negative charges, one body to another body. Okay, so when you rub your plastic scale through your dry hairs, then it attracts some piece of papers. Okay, then it attracts some piece of papers, because some basically electron get transferred. Okay, some electron get transferred. So we always talk about transfer of electron always get transferred, because positive charge means proton bound in nucleus, and electron basically exists in outer shells. So it depends on matter. If they are not tightly bound with their orbits, then basically they get transferred. So whenever you rub a glass rod with a silk cloth, so in that case glass rod get positively charged, because some electron get transferred from glass rod to the silk cloth. Okay, so I'm again repeating, always electron gets transferred from one body to another body. Okay, and which body lose electron, it depends on its matter, what kind of material it is the body has. Okay, so next point which I'm going to discuss is charging a body, what kind of method we use for charging a body. Okay, and after charging a body, I will discuss some basic property of charge. Okay, some basic properties of charge. So next, is there any question up to now? Okay, first I discussed what is definition of charge, and very basic points related to charge means charge is scalar, charge has unit coulomb, and one electron has charge 1.6 into 10 raised to the power minus 19, and what kind of body is positively charged, negatively charged, or a neutral body. And next point which I am going to discuss is charging of a body. What kind of method we use for charging a body? Methods for charging a body. Methods for charging a body. Okay. Methods for charging a body. So there are basically three ways through which we charge a body. Okay. So the first one is charging by conduction. The first one is charging by conduction. Charging by conduction. And another is charging by induction. Charging by induction. Okay. And another is charging by friction. Charging by friction. Okay. So let's start with our first point, which is charging by conduction. Charging by conduction. Okay. So let's start with charging by conduction. Okay, conduction. So how we can charge through conduction? So when I put a body in contact with a charged body, okay, when a charged body put in contact with a discharge body, a discharge conducting body, okay, conducting body, then discharge body gets charged. Okay. So when I charge, it's better to, if I use charge conducting body, I will discuss what is this conducting word. Means conducting means if there is easy flow of electrons. Okay. So if a charge conducting body put in contact with discharge conducting body, then discharge body gets charged. Let us try to understand through example. Suppose if I take a body, okay, which is charged. What kind of charge it has? It is negatively charged. 1, 2, 3, 4. It has 4 negative charges. Okay. And if I am taking another body, suppose this is another body. which is neutral. Neutral means it has equal number of positive charge and equal number of negative charge. So we called it has discharge, means it doesn't have any kind of charge. Okay, it's a neutral. So next, if I put in contact with this body, suppose this one, and I use here. So when I put in contact with this body, then what happened? The charges get shared. Charges get shared. How can we share this charge? Suppose this body has negative 4e electrons, negative 4, and it has 0. So what the method is they will share charges like minus 4e plus 0 by 2, and again minus 4e plus 0 by 2. So in this case, what happened? This minus 4e plus 0 by 2 means this will get cancelled out. So minus 2e, and this is again cancel out, minus 2e. So both bodies have minus 2e and minus 2e charges. Minus 2e and minus means both have now 2 charges. Is it clear? So a body has 4 negative charge and a discharge body, we put in contact with these 2 bodies, then what happened? They shared electrons. One body has negative 2 charges and another body gets negative 2 charges. What is the method? Just add these 2 charges and divide by 2. So in this way you can charging by conduction. Okay, now let us take another example. Suppose okay, example. In this example I am taking both charge bodies, both charge bodies, but their charges are different. Okay, this body has minus 4e electron, and another body I am taking minus 8e electron. Okay, so if I put in contact these 2 charges, these 2 bodies, then what happened? If I put in contact the first one and another one, so what happened? They will share their electrons. So in this case, minus 4e minus 8e divided by 2, both are negative, so they will get added, and it has minus 8e divided by 2. So how many charges both the bodies? How many charges both body will get? Tell me. It is minus 6 electron and minus 6 electron. Is it clear? All of you? Hishma, Saifullah?
Yes, sir.
Yes, sir. Okay. So next, I'm going to discuss. I'm giving a small problem. Tell me how charges get shared. Suppose I take example in which this body has plus 4e charges and this body has 0 charges. So tell me, if I put in contact these 2 spheres, these 2 bodies, then how many charge on both the bodies? Give me the answer. Anyone? Anyone? Give me the answer. Drop me a message. Hishma answered, I think. And so again the method is same. If I put these charges in contact, so first one has plus 4e plus 0 divided by 2, another is again plus 4e plus 0 divided by 2. So in this case, both the spheres, both the bodies have +2 each charge, and then again it has +2 each charge, means 2 plus 2 plus. Okay, so this is we called charging by conduction. Charging by conduction. Next, charging by induction. Okay, is it clear? Any question related to this charging by conduction? Is any question? If any question, any doubt related to this topic, this point, charging by conduction?
No, sir.
Okay, no. So now we can go to the next, which is charging by induction. Charging by induction. Okay, so next is charging by induction. Okay, so induction, we charge by induction without putting in contact of two bodies. Okay, we will in this time we will not touch two body each other. Okay, so how can we apply this method? Suppose I am choosing a body. Okay, suppose I am choosing a conducting body which is neutral in nature. So neutral means it has equal number of positive and negative charge, positive, negative charge, positive, negative charge, positive, negative charge, positive, negative, positive, negative. Okay, it has equal number of positive and negative charge. So that's why it's neutral in nature. And what I will do, I will bring a rod. I will bring a rod, positively charged rod. Positively charged. It is positively charged rod. Okay, so positively charged. So what happened when I bring this positively charged rod near to this conductor which is neutral? So what happened due to these positive charges, as I told you, due to this positive always attract negative charge. Okay, so due to this positive charge, what happened? Due to this positive charge, what happened? The negative charge basically appear at one end. The negative charges will appear at one end. Okay, so let me draw another diagram. Yeah, so that I can clearly show you what happened in this case. Few electrons get appeared at this point. Okay, and another get same positive, negative, positive and negative, negative, positive, negative, negative, positive. And if two electrons comes at the one end, then what happened? Similarly, two positive will appear at this end. Okay, so why this happened? This happened because I bring this positively charged rod very close to at one end. So one in at this end, there's the number of electron will increase, and here there is a deficiency of electrons. So one part is get positively charged and one part get negatively charged. So this part gets negatively charged, negatively charged, and this part gets positively charged. Okay, okay, so this we call charging by induction. This we call charging by induction. Okay, okay, so this is any question related to this point, charging by induction? Okay, so now if you understand this, so if I want to make a pure positive charge or pure negative charge body, then how can I do it? Okay, so let's again, if I'm taking two conducting spheres, if I'm considering two conducting spheres, if I'm considering two conducting spheres which are neutral in nature, suppose first conducting sphere, okay, and there is another which is identical to this one, another conducting sphere. Okay, so it has equal number of positive and negative charge which are neutral. Okay. So what happened, what I'm going to do, I am just again bringing a rod of positively charged rod very close to this sphere. A positively charged rod very close to this sphere. So what happened, this, the one portion of this sphere, what happened, this portion gets negatively charged, negative, negative, negative. Okay, just like the previous example. And due to this negative charges, what happened, the another end of that sphere, because previously they have equal number of positive and negative charge. So what happened when I bring this positively charged rod to this neutral conducting spheres, then another part gets equal number of positively charged. Okay, positively charged. And now next part, what I'm going to do, now I am going to detaching these two spheres. Now what I'm going to do, I am just detaching these two spheres. I'm just putting my rod close to -1 sphere, and what I'm going to do, I'm just if I detach these two spheres, the first one and this is your second one. So what happened in this case, now one sphere totally gets negatively charged, 1 2 3 4, and another sphere gets positively charged. So in this way you created a pure negative and pure positively charged sphere. Okay, previously they are neutral, they have equal number of positive and negative charge. By bringing a positively charged rod, you created a pure negatively charged sphere and pure positively charged sphere. So this is we call charging by induction. This is we call charging by induction. Is it clear, or any question? Anyone? Is it clear? Yes or no?
Yes, sir.
Hishma, Saifullah, and Minashi.
Yes, sir.
Okay. Maziha.
Yes, sir.
Okay. And Lamya. Okay. So now the last one, the last method which I'm going to tell you is charging by friction. Next part I'm going to show is charging by friction. So charging by friction is quite easy. Means charging by friction. Charging by friction. Okay. So charging by friction. So when we rub two bodies, as I told you, for example, when I rub a silk cloth, when I rub a glass rod with a silk cloth, then in that case what happens, you are using friction. Due to this friction, heat produces, and due to this heat, some electron get transferred from one body to another body. Okay, so if I rub these two hands, okay, so due to this friction, some electrons get transferred from one body to another body. This is we call charging by friction. Okay, by rubbing two bodies. Okay, so due to this rubbing, heat produces, and due to this heat, some electron loses their surfaces. Which body will lose first? Which body? It depends on material, what kind of material it is. If it has a material which is whose electron is loosely bound with their orbits, then that body will easily first lose his electron. In silk and glass rod will lose electron first. Okay, so charging by friction means we are rubbing. Okay, if I consider a body, two bodies, and if I rub these two bodies, if I rub these two bodies by rubbing. What happened? One body, the electron transferred, and one body gets negatively charged and another body gets positively charged. Okay, so you can write when we rub two bodies, then due to friction, electron gets transferred from one body to another body that is called charging by friction. Okay, okay, is it clear?
Yes, sir.
Okay, so now up to now what we studied, I start with let's take a small quick revision. I start with the definition of charge. What is charge? So I told you charge is intrinsic property of fundamental particles. After that, I discuss types of charge. So I show there are two kind of charge. One is positive charge, and another one is negative charge. And next I discuss what is the charge is a scalar quantity. Okay, charge is a scalar quantity, and the SI unit of charge is Coulomb. And the charge on electron and proton is 1.6 into 10 raised to the power minus 19. As I told you, the magnitude is same. The sign is positive and negative. In electron we consider negative, and in proton we consider positive, but the magnitude means amount is same, which is 1.6 into 10 raised to the power 19. After that, I take a very small difference of mass and charge. Okay, so mass has positive charge, both exist in both types, positive and negative. Mass corresponds gravitational force, charge corresponds electrostatic force, which is positive and negative. And after that, I discuss charging of a body. Charging of a body, first I discuss what is a positively and negatively charged body. Okay, and after that, a method of charging. In method of charging, I show charging by conduction, charging by induction, and charging by friction. Okay, so all the method I discuss very briefly. I hope if is there any question related to these methods, then you can ask. If no questions, so we can go to the basic properties of charges. Okay, so now next is basic properties of charges. Basic properties of charges. Basic properties of charges. Okay, so what are basic properties of charges? There are three basic properties of charges. The first one is additivity. Additivity. Okay, the another one is quantization. And the last one is conservation. Okay, so let's start with the first property, which is additivity. Okay, the first property, which is additivity. additivity. Okay. So what is additivity property? So charge is a scalar quantity. So charge is a scalar quantity. So scalar quantity, just as you add mass, you add just charges. Okay. So if I consider a body, okay, if I consider a body, it has number of charges. Suppose it has charge q1, q2, q3, q4, etc. Suppose it has charge, suppose q1, okay, another charge is q2, another charge is q3, and up to its body has total qn charge. Then we define net charge. Q net charge is equal to q1 plus q2 plus q3 plus up to qn. Okay. So we can write this in the statement form. The statement form says the total charges of a system is the total charges of a system. The total charges of a system is the algebraic sum of all the individual charges Okay. So let's take example. Suppose I am choosing a system. Suppose for example, suppose I'm choosing a system. This is example. Okay, it has suppose plus 2e charge, minus 4e charge, plus 3e charge, and minus 6e charge. So what is the total charge? What is q net? What is the net charge of this body? Tell me what is the answer. Try to solve it. What is the answer? Okay. How much charge this body has? Anyone? Okay, so let me explain. It has a charge. As I told you, you just have to add all the charges. The first one is plus 2e, the another one is minus 4e, the next one is plus 3e, and the last one is minus 6e. So if you add all these charges, so what is the resultant? This minus gets minus 10, and this 5. So minus 10e plus 5e. So the answer is minus 5e. Okay, is it clear? So let me take another quick example so that you can learn. Okay, suppose I am taking another body. Okay, it has plus 5e. Okay, q1 is equals to plus 5e, q2 is equals to minus 6e, q3 is equals to e, and q4 is equals to 2e plus और ये भी the q1 is also plus. q1 is plus 5e, q2 is minus 6e, q3 is plus e, and q4 is plus 2e. Now tell me the net charge over this body. Give me the answer. Very quick answer. Okay. Tell me the answer. Lamya, Saifullah, what is the answer?
Plus 2e charge.
Okay, so plus 2e charge. So net charge is plus 5e minus 6e plus e plus 2e. Okay, so 5 plus e, 6 plus 8e and minus 6e, so that is plus 2e. Okay, so this is we call additivity property. So this property exists due to the charge is scalar. Charge is scalar. If charge is a vector, then this will not happen. Okay. Now next property is quantization. Next property is quantization. 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 Okay. So means the quantization property says that charge is quantized. Okay. So first I'm writing the statement. Charge exists. Charge exists in the integral multiple of integral multiple of fundamental charge E. Okay, as I told you, the fundamental charge means the minimum amount of charge is 1e, the charge on electron or a proton, which is 1.6 into 10 raised to the power minus 19 C. So charge exists with the in the integral multiple of this fundamental charge. Means we always say that Q is equals to 1e, 2e, 3e, 4e, 5e, 6e, or NE. Okay, NE. So suppose you are counting. Counting floors on a building. So you consider is ground floor, first floor, second floor, third floor, fifth floor, or nth floor. Okay, so in this case, floors are quantized. Or if you talk about steps, okay, stairs. Okay, so first step, second step, third step, fourth step. Okay, so this E is a fundamental charge, and we consider we always talk about charge as the integral multiple of this fundamental charge, which is Ne. So as I told you, charge can be positive and negative. So the formula is Q is equals to plus minus Ne. Q is equals to plus minus Ne. Okay, this is the important formula. The small numerical can be asked over this small formula. Okay, so as I told you, the charge on electron, the charge on electron is minus E. Okay, charge on proton, proton is plus E. Okay, so these are two important charges. Another charge is which is very famous, charge on alpha particle. Charge on alpha particle. Alpha particle. What is alpha particle? I will discuss it in your modern physics chapter. But now, now you just remember that alpha particle has 2e charge. It has 2 protons. Alpha particle has 2 protons, so it has charge 2e. Okay, so these two are very important, electron and proton. You just remember electron has negative E minus E charge and proton has plus E charge. And what is the value of E? It has a value 1.6 into 10 raised to the power minus 19 coulomb. Okay, so this is we call quantization of charge, means charge is quantized. It exists in the integral multiple of fundamental charge, which is E. Okay, is it clear? Okay, so this is second property of charge. Now the next property, which is conservation of charge. The next property is conservation of charge. Next property is conservation of charge. Conservation of charge. So what is conservation of charge? What is conservation of mass? Anyone? Conservation of mass. Okay, so we can't create or destroy. We can't create or destroy mass. We can convert mass one form into another form, but we can't create or destroy mass. Okay, it gets transformed. Same as charges, we can't create charge, neither be created, neither be destroyed. It exists in nature. But you can transfer charge from one system to another system, but you can't create or destroy charges. Okay, so this is we call conservation of charge. Or you can say the total charge of this entire universe is constant or conserved. The total charge of this entire universe is constant. Okay, so charge exists in nature as it is. Okay, so charges or charge neither be created, or neither be destroyed. Neither be destroyed. Neither be created, neither be destroyed. The important definition for your exam purpose, if this question asked in your exam that what is conservation of charge, then write the total charge of an isolated system, charge of an isolated system is remains constant. The total charge of an isolated system remains constant, and the entire universe is a isolated system, so you can say that the total charge of an entire universe remains constant. Okay, so the total charge of entire universe remains constant. This is we call conservation of charge. Okay, so these are some basic properties of charges. Okay, so these are basic properties. So this is all about charge. Okay, this is all about charge. What kind of this? The total lecture is based on charging of a body and some basic properties of charge. Okay, so what we studied today? We studied today what is charge. Okay, what is charge, and charging of a body, how you can charge a body, and some basic properties of charges. Okay. Okay, is it clear?
Yes, sir.
Yeah. So the next part we are going to discuss is related to force. Related to force means how these charges gets interact. How these charges get interact means, as I told you, when you put a positive very close to each other, they repel each other. Then what amount of force they actually apply? Okay, when they repel, suppose I bring two charges very close to each other. Okay, so when I bring two charges very close to each other, suppose this is a charge q1 and this is another charge which is charge q2. Okay, so this is charge q1 and this is charge q2. If both charges are positive, this is positive, this is positive, then what happens? They will repel each other. Means this Q1 will apply a force on Q2, and again this Q2 will apply a force on Q1. These two charges will apply some force on each other, so that's why they get repel. Okay, and if I again choose a charge Q1 and a charge Q2, okay, which is again this charge Q1 and this charge Q2, this time I am again taking a negative and negative, then they will again apply some force and they will repel each other. They will repel each other. And in third example, if I am taking two dissimilar charges, dissimilar charges, okay, one is Q1 and one is Q2, same Q1 Q2, but this time Q1 is positive and Q2 is negative. So this time they will apply a force in, okay, then this time they will apply a force to attract each other. In first case they are repelling, in second case they are repelling, in third case they are attracting. So the question is this, means they are applying some kind of force, they are repelling and they are attracting, means in that case they are applying some kind of force. Okay, so what amount of this force is, what amount of this force is, okay, this is the question. How can we find the force, okay, force of these two bodies which are repelling and attracting each other? Okay, so the very first calculation of this force was done by Coulomb. The very first calculation of this force was done by Coulomb. Coulomb calculated if we bring two charges at a sufficient distance, then what kind of strength of force exists? What kind of strength of force exists? Okay, so actually this I will discuss in my next lecture. So the next lecture will totally based on this Coulomb force. Today I am stopping here. Okay, so that you can go and take a brief revision of your charge lecture. Okay, so I'm stopping here because I want to be very precisely this lecture about charges. Okay, this lecture is all about charges, so that you can go and take a revision of your charges, so that when you come tomorrow I will discuss the Coulomb force. What is Coulomb force? The total lecture will be based on the Coulomb force. Okay. Okay.
Yes, sir.
Any question? If any question, then anyone can ask with me. Any question related to today's lecture? Or okay, so I'm closing today's class.
No, sir.
Yeah, hello. Hello.
Sir, you're audible.
Yeah, I'm audible. Okay. Okay, guys. So I will continue my class from tomorrow. From this Coulomb force. Okay.
Okay, sir.
Okay, sir.
Okay. Okay. See you guys tomorrow.
Thank you.
Thank you, sir.
Oh,
Thank you,
okay.
sir.